Hello, I am Emre Koçyiğit. In this video series, I will explain linear regression models in machine learning. I will use this presentation to explain the linear regression model, and this is the presentation outline. First of all, I will explain the promises of the video series. Then I will show the big picture of linear regression in the machine learning world. After understanding the big picture, we will see the fundamentals of linear regression, important points, and we will see how to evaluate the linear regression models. What are the error metrics? Then I will show a couple of examples on Jupyter Notebook. And in the bonus section, there will be some questions which can be asked in the interviews, are also very important to understand the topic. Okay, let's start with the promises. At the end of this video series, you will be able to understand linear regression, which is one of the most popular topic in the machine learning world. Actually, it's a hello world of machine learning journey. But before explaining the promises, I want to ask a question. Probably most of you know this movie scene. This scene from Matrix, and this is Neo. My question is, do you know this character? Let me answer the question. Actually, she is an oracle. She is not a human. Actually, Neo also not human in this scene. It's an agent of human, and this is very advanced and sophisticated program, computer program. And at the end of this video series, you will have one ability of this advanced program, using historical data to predict the future. Of course, it is more complicated, more sophisticated, and it uses some heuristics also, but in linear regression model, our problems will be more simple. But you can build some predictive model using linear regression. To sum up, I can say that you will know what are the fundamentals of linear regression, what are the important points, where is the position of linear regression in the machine learning world, it's quite important, why it is useful, why not, when can we use it, when linear regression failed. And of course, after understanding the linear regression model, we will see how to implement to solve some real life problems. For example, we can estimate the price of houses in a specific zone. Of course, there are some requirements, but basically you will use some historical data to predict future. Now let's look at the big picture. It's quite important, especially in machine learning journey. Before each topic, I strongly recommend to understand the big picture of specific topic. When I say big picture, I mean if you know that you are here, but if you don't know the map, you cannot understand your relationship between the neighbors, which directions, which paths are possible. You cannot see the hierarchical relationship between the topic and the machine learning world. So you should always understand the big picture, what is the position of that specific topic. So in this case, we will see linear regression. Let's look at it together. So linear regression is a subset of regression family. And when we say regression, we will talk about continuous data. We will have dependent and independent variables. So we will use linear regression to regress our data in a linear model. So basically, we will deal with continuous data, like the price of houses, electricity consumption of a town, so any continuous data. But also there is another family, classification family. When we say classification, we will talk about some categorical qualitative data like Democrat and Republican, or secure email, spam email, or size of some, let's say, clothes like small, medium, large. I will not give the details of classification algorithms and all regression algorithms. I will just try to give you a perspective from linear regression to the machine learning world. So these are subset of supervised learning family, and when we talk about the supervising in the training phase of machine learning, there are four types: supervised, unsupervised, semi-supervised, and reinforcement learning. So within these four types, linear regression is a part of supervised learning. When I say supervised learning, remember our machine learning model should be trained with inputs and outputs. So datasets should be labeled. We will give both questions and answers in the training phase. And of course, these are subset of machine learning, and machine learning is a subset of artificial intelligence. We can also say that some computer science and other disciplines contribute to this field, but just try to understand the position of linear regression in this world. So if you are using linear regression model to predict price of the house, you can say that you are you are developing some artificial intelligence based application. But here there is an important point. Actually, the artificial intelligence and machine learning is younger than linear regression because, for example, Arthur Samuel used artificial intelligence term in 1959, but the linear regression, especially the regression term, was used in 19th century, so it's quite older. Because linear regression is also a part of statistical techniques, and most of the fundamentals of linear regression is a contribution from statistics. So we can say that linear regression position in an intersection point of statistics and machine learning. But it's not only about statistics. I will elaborate this part. Okay, when you talk about linear regression, you should also understand and know what is linear. Of course, this is a default linear line, right? Everybody can draw this kind of linear line from the high school knowledge or college knowledge. This is also a linear line. This is also a linear line. And this is also linear. Because remember the equation y equals m times x plus b. If you can represent with this equation, then it is a linear line, right? So when we talk about nonlinear, it can be polynomial, exponential, sinusoidal waves. Basically, if you cannot express the function with y equals m times x plus b, then it's not linear, right? Okay, now let's look at the regression term. If you look at the dictionary, you can see that regress is return to a former or less developed state. So it is a good explanation. So think that we have this kind of data like population and consumption. These blue points are representing consumption amount for each population. Okay, basically we will try to regress this data distribution to this linear function, which is less developed state, right? And if you can express this data distribution with this line, with this less developed state form, then you can predict the consumption amount for any other unknown population. Another important point here is if your data set is like that, let's say it's not sufficient or representative, your model, your linear model will be something like that to represent this data distribution. But if it is not sufficient, then the model will be wrong. If the data set is something like that, then the model should be like the purple line, right? So the first lesson is the regression model, linear regression model, is strictly dependent on the data quality. If data is not sufficient or representative, then the model will be wrong. Let's look at some example. We have size and price information of the houses in a specific zone. When I say 100, it is $100,000, and this is 50 meters square. If you plot this data, we will see something like that: price and size will be our independent variable, and the price is our dependent variable because price values will change according to the size inputs. And if you plot this, we will see something like that. You can see a perfect linear line, right? But of course, this is not life. In real life, but of course, this is dreams, but in real life, the values will be not perfect like this, right? If you plot this let's say this is our real life data. If you plot this real life data, we will see something like that, the purple ones. Still, it's quite good, but of course, I intentionally give these values to show this linear relation. As you see, we can still represent these purple points with this linear line, right? For any other size information, we can predict the price value. So this is the big picture. This is the introduction of the topic. Now let's look at the fundamentals of linear regression.